Hey, this is Mr. Masonette, and what we're going to do in this tutorial is we are going to practice working with exponential expressions. So let's start by evaluating this expression right here. Now in this expression, notice that for the numerator and the denominator, we have the same base. We have a base of 5. And whenever you have the same base for an exponential division problem, the rule is you take that base and then you take the exponents of that base and you simply subtract. But you have to start with the exponent that is part of the numerator. So we're going to take this 4 here and subtract it with 6. And 4 minus 6 is negative 2, so that gives us an expression 5 to the negative second power. Now, when dealing with negative exponents, what we should understand here is really we are dealing with a fractional value. Now, a big misconception is that some kids think when they first learn this that a negative exponent will give you a negative answer, which is not true. A negative exponent just simply indicates a value that is less than 1 whole, so 0 point something or a fractional value. So when you get a negative exponent, what I like to do is start by just writing a denominator of 1. We're going to turn this into a fraction. Now, what we do then when we have a negative exponent is we just write the reciprocal of this. So we're going to take this and we are going to switch the numerator with the denominator. And when you flip it over, it ends up turning this exponent positive. So what we have here is 1 over 5 to the second power, which would be equal to 1 over 25. So 1/25 is the answer. Now, there's another way that we could have gone about this, and here's how we could have done this problem. So let's say we took 5 to the 4th power and we write it in expanded form. And we do the same thing at the bottom. We have to take 5 to the 6th and write it out 6 times. Now, you don't have to solve it this way, but this is a way just to demonstrate how we can quickly come up with 1/25. Now, when you're dividing and you have the same numerator and denominator, those can be canceled out to equal 1 because 5 divided by 5 is 1, so we can just write 1 over 1. So we have 4 pairs of 5 here that will cancel out. Now, notice on the top, all we have remaining are 1s. So if we multiply these straight across, that would give us a product of 1 for the numerator. And on the bottom, if we multiply straight across, we would have 25. And that's how we came up with 1/25. Now, the original way that I did this is just demonstrating the rule that when you are dividing exponential expressions with the same base, that you subtract the exponents. However, this is not the way I usually like to solve a problem like this. So let me show you a really quick, easy way that you could have evaluated this expression. So what I like to do is I like to just say, okay, where do I have more 5s, on the top or the bottom? Well, because the bottom is raised to the 6th power, we have more 5s on the bottom. So then what I like to do is just say, okay, how many more 5s do I have on the bottom than the top? Well, 6 is 2 bigger than 4, so we would say we have 2 more 5s on the bottom. So I would immediately turn this into 5 to the second. And then on the top, I would understand that all of these cancel out to be the number 1, so I just stick a number 1 up there. Now I have 1 over 5 to the second, which I know will be 1 over 25. So this is how I actually like to solve an expression like this. However, your teachers may force you to use this rule here, which is still important to understand. All right, let's go on to another example. Okay, for this example, we have to find the value of this expression and we have to express our answer as an improper fraction. So we have negative 3 1/3 raised to the 3rd power. So what we're going to do first is we're going to take this mixed number and we are going to write it as an improper fraction. So we are going to rename it. So let's take negative 3 1/3 and rename it as negative 10/3. Now, if you need a quick refresher on how you change this to an improper fraction, remember the denominator does not change, so we have a 3 here, so we just rewrote the 3. But to come up with this 10 here, we do two things. We take our denominator, multiply it by our whole number here, and 3 times 3 is 9. And then you take that product and you add to it the numerator. So 9 plus 1 is 10. Now, this value here, negative 10 thirds, is raised to the third power. So we're taking negative 10 thirds and multiplying it by negative 10 thirds by another negative 10 thirds. Now, what we must remember here is that when you are multiplying an odd number of negatives, your answer is going to remain negative. So one thing that we should remember about working with negatives and multiplication is that when you have an odd number of negatives, your answer is going to remain negative. When you have an even number of negatives, your answer is going to be positive. So we know that right away we're going to have a negative answer here. So let's multiply our numerators here. We have 10 times 10 times 10, which is 1,000. And for the denominator, we have 3 times 3, which is 9, and 9 times 3 is 27. So our answer is negative 1,027. All right, let's go ahead and do another example. All right, we have to determine which of these 4 choices is equivalent to this expression right here. Now remember, when working with exponential expressions that have the same base, you can just take the base at the top and then take its exponent and subtract it with the exponent at the bottom. So we have to take 6 and subtract from it negative 4. Now remember, when subtracting a negative, or when you have 2 consecutive negatives, the rule is you have to turn that positive. So what we end up coming up with here is 2 to the 10th power, which is equivalent to choice C. Now, another way that I've worked with this problem in the past is like this. So whenever you have a fraction and you have a positive exponent and a negative exponent, what you can do is anything that's positive, you can keep where it is. And anything that is negative, what you can do is you can migrate that part of the expression to the other side of your fraction bar. So I'm going to take this and just write it at the top. And then you can automatically turn that exponent positive. And if there's nothing remaining at the bottom after moving pieces of that expression, you can just hold that place with the 1 there. Now, when you're multiplying bases that are the same, the rule is you actually add those exponents. So we would take our base of 2 and then take our exponents of 6 and 4 and add them together, which would give us 2 to the 10th power over 1. And remember, when your denominator is 1, you really don't need it. So we still end up with the expression 2 to the 10th power. All right, let's go ahead and do another example. All right, we have to determine which of these 4 choices is equivalent to 5 squared times 5 to the negative 3rd power. Now, when multiplying bases that are the same, we take the exponents and we add them. So let us rewrite our base, 5, and then take the first exponent, 2, and add it to negative 3. Now, positive 2 and negative 3 is negative 1, so this is going to be 5 to the negative 1st power. And when you have a negative power, that represents a fractional value. So what I can do is I can immediately turn this into a fraction by writing a 1 at the bottom, and then just write the reciprocal of this value. So I'm going to take this 5 to the negative 1st and move it to the bottom, or write it as the denominator. So it is going to become 5 to the positive 1st power, and then this 1 at the bottom is going to go on the top. Now remember, whenever you have a 1 as an exponent, you really don't need it, because anything to the 1st power is going to be equal to whatever the base is. So 5 to the 1st power is simply 5. So we end up with a value of 1/5. So we would say that choice B is equivalent to this expression right here. Now, another way we could have done this, although I would not recommend it, but sometimes doing things an alternate way will give you deeper understanding. You could have taken 5 to the second power, which is 25. And then you could have taken 5 to the third power, and ignore that negative for a moment, which would be 125. But then you would write it as 1 over 125. Because remember, a negative exponent indicates a fractional value. So if 5 to the third power is 125, then 5 to the negative third power would be 1/125th. So now we have 25 over 1 times 1 over 125. And we could just multiply straight across, which would give us 25 over 125. And then we could reduce that fraction, and that would give us 1/5. Or we could have used cancellation within the problem itself. We could have divided 25 into this numerator and into this denominator. 25 goes into itself once, and 25 goes into 125 5 times. So the numerator is 1 times 1, which is 1, and the denominator is 1 times 5, which is 5, still giving us a value of 1/5. However, if we know our exponent rule, that when our bases are the same, we simply add the exponents, we could quickly come up with an answer. All right, let us do one more example. All right, with this example, here is what I am going to do. So what I'm going to do is I'm going to take anything that is positive and leave it where it is. So notice at the top we have a 3 to the second power, and on the bottom as well. And then anything that is negative, I am going to rewrite it on the opposite side of the fraction bar as a positive exponent. So 3 to the negative fifth is going to be rewritten as 3 to the positive fifth power. And then we have 3 to the negative third power, which we're going to rewrite on the numerator side of our fraction bar as 3 to the positive third. So whenever you have a negative exponent, you can take that entire entity and just rewrite it on the other side of your fraction bar, and you have to make sure to write that as a positive. And the reason we can do this is because, remember, a negative exponent really just represents a fractional value, which is really just the reciprocal of what the positive would be. For example, we know that 3 to the third power would be 27, but because it's on the bottom, that would be 1 over 27, and then we would have to flip that over, and that would be 27 over 1. And now it is on the top. Now, what we're going to do next is this. We can right away just take 3 to the second on the top and 3 to the second on the bottom and just cancel them out. Basically, we're taking a value and dividing that value by itself. It is the same thing. So when you divide something by itself, it is always equal to 1. Now, what I notice here is we have more 3's at the bottom than on the top. In fact, we have 2 more 3's on the bottom, so I can just say we have 3 to the second power on the bottom, understanding that everything on the top is going to cancel out to be 1. So then I can write this as 1 over 3 squared, which is 9. So this expression is going to be equal to 1/9. Now let us understand that this is just one way of solving this problem. There are many ways we can approach this problem. For example, let us go back to the original problem here and do this. Let's say you just wanted to look at the numerator separately from the denominator. What you could do then is you can take the same base of 3 and then take the exponents, and you can go ahead and add those exponents. So we have 3 to the negative fifth, and then we have to add that positive 2 there. And then for the denominator, we have the exponents of 2 and negative 3, so we have to take 2 and add it to negative 3. Now, What we're going to do next is take our numerator and write that as 3 to the negative third power, because negative 5 and positive 2 is negative 3. And for the denominator, we're going to rewrite that as 3 to the negative first power, because 2 and negative 3 is negative 1. Now what we can do at this point is this. Because we are dividing the same base, we can take that base of 3 and we can take the top exponent and we can subtract it from the bottom exponent. Remember, when dividing bases that are the same, we can subtract their exponents. Now we are subtracting a negative here, so we have to recognize that we have to turn those into positives, and that is going to give us 3 to the negative second power. Now remember, 3 to the second power would be 9, but because it is negative, we would write the reciprocal of that. So the reciprocal of 9 would be 1/9, which is the same thing that we got when we did it using a different strategy.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and activate notifications so you can be informed as I upload new math tutorials that just might help you with your math homework. Until next time, this is Shane Masonette with Masonette Math.